Welcome to this explainer on a topic that is just absolutely mind-bending. For decades now, we've heard that quantum computing is going to completely revolutionize our world. We're talking about the power to instantly solve problems in drug discovery, materials science, or encryption that would literally take standard computers millions of years to crack. But there's been this massive, seemingly insurmountable physical roadblock permanently standing in the way of that future. Well, what if the solution to finally building a working, reliable quantum computer didn't actually involve building a better physical quantum chip at all? What if the answer was actually building a smarter artificial intelligence to control it? Today, we are unpacking NVIDIA's masterstroke in the quantum realm and exploring how their newly announced Ising AI is completely changing the landscape of computing as we know it.
Okay, let's dive into this. Because to truly understand the genius of NVIDIA's solution, we first have to wrap our heads around the sheer, almost incomprehensible scale of the problem. As this quote perfectly captures, fixing errors in a quantum computer using traditional classical computers is literally like trying to catch a bullet with a pair of tweezers. I mean, think about that. The quantum realm is almost unimaginably fragile. Qubits, which are the fundamental subatomic building blocks of a quantum computer, they operate at speeds and in states of matter that totally defy our everyday understanding of physics. When a quantum system generates an error, it happens with such explosive speed that our absolute best classical computers simply cannot run their error correction algorithms fast enough to fix it before the whole system crashes. It's a fundamental mismatch. You essentially have a slow mechanical machine trying to fix a lightning-fast subatomic process.
And you know, that speed mismatch inevitably leads to what is probably the most terrifying word in a quantum physicist vocabulary: decoherence. This is the ultimate villain of our story here. Decoherence is the physical chaos that acts as the core roadblock hindering all of quantum computing. So a qubit exists in this highly delicate state called superposition, which is exactly what allows it to perform those massive, simultaneous calculations. But think of superposition like a towering, incredibly fragile house of cards. The exact moment that qubit interacts with even the slightest bit of environmental noise, maybe a tiny microscopic fluctuation in temperature or a stray electromagnetic wave passing through the room, that delicate quantum state instantly collapses. That collapse is decoherence. Before traditional algorithms can even register that a problem is happening, the qubit has already lost all of its vital information. It's a desperate race against time, and frankly, classical computing was always losing.
But the rules of that race completely flipped on April 14, 2026. On this day, NVIDIA stepped into the arena and triggered a massive paradigm shift. Now, they didn't come forward with a giant supercooled chandelier of new physical hardware. No, instead, they announced the Ising models. This was the world's first open-source suite of artificial intelligence models designed specifically and exclusively for quantum computers. Instead of fighting incredibly complex physics with more complex physics, NVIDIA decided to fight quantum chaos with software. They literally brought artificial intelligence right into the subatomic realm.
And this brilliantly illustrates the technological pivot we're talking about here, because it entirely changes our relationship with time. You see, classical algorithms are inherently reactive. They have to wait for an error to happen, then they observe it, and then they scramble the calculated fix. But as we just established, by the time they react, the qubit has already decohered. It's useless. NVIDIA's Ising AI models, on the other hand, are predictive. Because they're powered by highly advanced machine learning, they don't wait for the error to occur at all. They actually anticipate the error based on incredibly complex patterns and issue the correction almost instantaneously. It's basically the difference between trying to catch a falling glass of water and simply knowing exactly where to place your hand before the glass even slips off the table. So, you might be wondering, how exactly do you build a predictive brain capable of anticipating the chaotic quantum realm? Well, you feed it chaos. NVIDIA built this ultimate cheat code by utilizing deep neural networks and training them on massive datasets of raw quantum noise. By analyzing endless simulations of how qubits fail under all these different conditions, the AI learned to spot the hidden underlying patterns of decoherence. We're talking about patterns that a human engineer or a classical algorithm could just never possibly see. The end result is an AI engineered to act as a dedicated control plane. Think of this control plane as this invisible layer of intelligence hovering constantly above the physical hardware, acting like a master conductor, pulling the strings of a chaotic orchestra to keep everything in perfect stable harmony.
Now, what's really interesting about this slide is that this predictive approach doesn't just work in theory. It completely obliterates the previous benchmarks. NVIDIA's AI decodes quantum errors 2.5 times faster than the absolute best classical algorithms in existence. And look, when we're talking about a realm where survival is literally measured in fractions of a microsecond,
A 2.5x speed increase isn't just some nice, iterative optimization. It is the literal threshold between a perfectly functioning quantum computer and an incredibly expensive, totally useless piece of freezing cold metal. It actually buys the qubits the vital time they need to complete their calculations.
But hey, pure speed is pretty much useless without precision, right? You can't just fix things fast, you have to fix the exact right thing. And that's where the second half of this breakthrough comes in. The Ising AI models are an astonishing 3 times more accurate at identifying and correcting these really subtle errors. So by combining that blistering predictive speed with this level of pinpoint accuracy, NVIDIA's AI effectively acts as a stabilizing force field wrapping around the chaotic quantum environment. It tames the wildness, turning the inherently unstable world of qubits into a reliable, rock-solid foundation for next-generation computation.
So the crucial point is really understanding the aha moment of their business strategy here. NVIDIA's approach is absolutely brilliant because it's entirely hardware agnostic. They are establishing what we call the macro control plane. Consider the landscape of the tech world right now, okay? Google, IBM, Microsoft, countless highly funded startups. They are spending billions upon billions of dollars in this brutal, cutthroat race to build the best physical quantum chip. And NVIDIA? They are perfectly happy to sit back and let them fight it out. They honestly don't care who wins the hardware war, because whoever ultimately builds the best chip is still going to need a brain to run those fragile qubits. NVIDIA is positioning itself to be the universal intelligence that controls all of them, regardless of whose logo is printed on the hardware.
Let's move on and see how this builds on their past successes, because to truly appreciate the genius here, we have to look back at the master playbook CEO Jensen Huang used to build NVIDIA's current empire. Back in 2007, NVIDIA launched a platform called CUDA as an open-source tool. It basically allowed developers to easily use NVIDIA GPUs for general processing. By making it open and totally accessible, CUDA eventually made NVIDIA the undeniable, ubiquitous backbone of the massive classical AI revolution we're living through right now. Fast forward to 2026, and they are executing the exact same masterstroke with the open-source launch of Ising for quantum AI. It's a perfectly mirrored historical parallel. They are taking an incredibly proven strategy from the classical world and applying it directly to the quantum future. By open-sourcing Ising, NVIDIA is building what you can think of as the quantum toll booth, creating this massive asymmetric leverage in the market. Here's how it works. Step 1. Give this incredibly powerful vital software away for entirely free. Step 2. Because it's free, insanely fast, and highly accurate, developers and quantum hardware companies are naturally going to adopt it. I mean, if you build a $100 million quantum computer, you are for sure going to use the best free AI available to ensure it actually works, right? That makes Ising the indispensable industry standard. And then, step 3. Once every major quantum computer in the world relies on NVIDIA's software layer to function, NVIDIA effectively controls the entire quantum ecosystem. The lock-in effect is absolute. They become the unavoidable toll booth on the highway to the future of technology.
So, for those of us tracking the bleeding edge of technology, why does this specific breakthrough matter so much right now? Well, because up until April 2026, a truly useful fault-tolerant quantum computer, meaning a system that can run indefinitely without crashing from microscopic errors, was universally considered to be many years, maybe even decades away. But by successfully bridging artificial intelligence and quantum error correction, NVIDIA hasn't just solved a highly complex math problem, they've fundamentally accelerated the timeline for the entire quantum future. They have taken quantum supremacy out of the distant realm of theoretical physics and placed it firmly into the near-term realm of scalable, actionable engineering.
Which brings us to the profound implication of everything we've explored today. We are actively watching the real-time convergence of the two most powerful technologies in human history, artificial intelligence and quantum computing. If NVIDIA successfully executes this toll booth strategy, if their AI truly becomes the invisible, indispensable architect stabilizing every single qubit on Earth, we have to step back and ask ourselves a vital question. If NVIDIA controls the AI brain of the quantum realm, who truly owns the future of computing? Keep your eyes on the quantum horizon, folks.